Good afternoon everyone, my name is Nuri Iman and today I will present our group assignment about the physics of archery along with my group mate which is William, Putri Nurin Syakina, Putri Alia and Raja Amirul Mukmin. To begin with, let me explain our chosen concept in the movie Avengers Endgame. In this movie, Hawkeye is teaching her daughter on how to hit the arrow at the center of the post which is archery board. There's a lot of physics concepts need to be considered and assumed when playing archery. This movie is the best example that we can provide calculation related to the chapters in Physics 1.
Now, let us look at physics concepts. For the first one is Newton's second law. The acceleration of an object is directly proportional to the net force acting on it in the same direction. Newton's second law is used for calculating acceleration of the arrow as there is force exerted on string and mass of arrow. Then, Newton's third law. When shooting an arrow, there is always an equal magnitude and opposite direction. Two forces acting on different bodies, so a resultant force is not equal to zero. Next, Hooke's law. The elongation of a material under stress is directly proportional to the applied force, provided it remains within the elastic region. Moreover, projectile motion. Archery is motion of an arrow under the influence of gravity. The path taken by the projectile is within a plane of 2D. Thus, the motion of the arrow must be separated into two components, which are component X and component Y, to analyze it. So acceleration will replace with gravitational acceleration, which is in value of 9.81 meter over second square for y direction component.
Let us move on to objective point. The first problem is to calculate the velocity of an arrow when it is released by a bow. After that, the second problem is to analyze how different factors can affect the velocity of an arrow, such as bowstring tension, draw force, and arrow mass.
In the calculation part, we can use Newton's third law, Hooke's law, Newton's second law to calculate the velocity of the released arrow. Then we only use the Newton's third law for the conformations. So we have to assume that the mass of the arrow is 0.05 kg, the bowstring displacement x equals to 0.6 meter, spring constant of the bow 500 Newton per meter. So the force, first we have to find the force that apply in the bowstring by using Hooke's law. We use the formula F equals to kx, so we apply for the number 500 times 0.6, we get 300 Newton. And then subsequently, we are going to find the acceleration of the arrow by using Newton's second law. F equals to ma is initially formula, and then we deduct it to a equals to f divided by m, which a is we have found for 300, and divided by 0.05 equals to 600 meter per second square. Then only we find for the velocity of the arrow at release using kinematics at the x direction. So we can use v squared equals to u squared plus 2as, or u equals to 0 meter per second since the arrow is at rest. So we apply for the number v squared equals to 0 squared plus 6 plus 2 times 6,000 times 0.6, and then we get for the velocity 84.85. Hence we can get a conclusion that the arrow is shooted with a speed of 84.85 meters per second. Alright, although we have calculated for the velocity of the arrow, but everything but there are a lot of external forces such as gravity. So everything was having gravitational pull. So we have to calculate for the arrow of weight. And because due to gravity, we have to use the formula W equals to mg, while the m is 0.05, where g was 9.81, and we get for the value 0.49 Newton. Right, let's assume that it stopped at 0.01 seconds. Then we have to calculate for the decelerations. We can use the formula A equals to the change in velocity divided by the change of time, which is 84.85 divided by 0.01 second. And we get for the 8,485 meters per second square with deceleration. Because we didn't show that the deceleration with a negative value, so the negative shows as a deceleration sign. So the impact force, we can use F equals to ma to find for it. 0.05 times 8,485 is equals to 424.25 Newton, and we get for the arrow resistance equals to 1.1 Newton, and the impact force on the arrow is 424 Newton. So we can calculate for the F for the force for the accelerations, which is our force has been calculated for 1.1. For the arrow resistance, 1.1 Newton equals to 0.05 for the mass of the arrow, and A we don't know, so we just deduct it, and we get for 22 meters per second square. So 6,000 minus 22 is equals to 5,978 meters per second square for the acceleration for the arrow due to the arrow system. And finally, we calculate for the V using the formula v squared equals to u squared plus 2as, and V we get for 84.70 meters per second.
For the next calculation, cover the motion calculation of an object. First, we assume object stop in 0.01 second and calculate the deceleration using resulting in 8,485 ms negative 2. Using Newton's second law, the impact force is determined as 424.25 newtons. Next, we analyze the vertical motion, solving for the time using the kinematic equation which gives. Finally, we calculate the horizontal distance traveled using resulting in 127.6 meters. In conclusion, this calculation helps understand the object motion, deceleration, and impact force is involved. This calculation analyzes projectile motion to hit the bullseye. Given an initial velocity is 84.85 meters per second at 5-degree angle, we can determine the vertical velocity component as 7.14 meters per second using vertical motion equation. We can solve for the time of flight, which is 1.51 seconds. Finally, we can calculate the horizontal distance using resulting in 137.6 meters.
This illustration shows the forces in archery across three sections. On the left, the archer pulls the bowstring, creating tension and experience the reaction force while standing stable with weak and normal forces. In the middle, the arrow moves forward due to the bow force while air resistance slows it down and gravity pulls it down. On the right, the arrow hits the target with impact force while the target remains stable due to the normal force and weight. In summary, our analysis of an arrow's motion demonstrates key physics principles such as velocity, acceleration, forces, and projectile motion. We successfully determined the velocity of the arrow and examined how bowstring tension and arrow mass influence its motion. Additionally, we observed that gravity plays a crucial role in affecting acceleration, which directly impacts the time it takes for the arrow to reach its target. The force of gravity also influences the vertical motion of the arrow, making it follow a curved projectile path rather than a straight trajectory. Finally, we use kinematic equation to calculate both the horizontal and vertical distance traveled by the arrow, taking into account initial velocity and external forces. This study highlights the importance of physics in understanding real-world motion, particularly in archery and projectile-based applications. This is the link for the chosen cutscene from Avengers Endgame, where Hawkeye teaches his daughter archery. This scene illustrates the physics concepts we discussed, such as motion, force, and projectile trajectory.